Okay, so sa problem na to, this is quite similar to the fish problem in the previous video, no? This time we are using milk. So reading the problem, we can see that the milk has been cooled, not freezed, no? If it's freeze, then it's going way beyond the freezing point, no? It's going beyond the freezing point rather. In this case, cooled lang, no? So from 27 degrees Celsius going to 3.33 degrees Celsius in 5 hours. In 5 hours, okay? So this should be pretty basic. From here, from 27 to 3.33, again you have what? 9,500 liters. Convert that to kilograms. So 1.03 kilograms per liter times, again you have your 0.94 kilocals per kilogram degrees Celsius. And again, the difference, no, in absolute temperature, that should be in 27 minus 3.33 degrees Celsius. Okay, pwede natin correcta na, no, since there are no other factors to consider. Since it is in 5 hours, 9,500 liters in 5 hours, then we can say that for every 1 hour, you have 3,600 seconds. And for every 1 kilocalories, you have 4.187 kilojoules, okay? Ano pa? It wants the unit in tons of refrigeration. Kilojoules per second is simply in kilowatts, okay? So for every 3.517 kilowatts, you have 1 TR, okay? So the answer here should be around around 14.4 tons of refrigeration, okay? So this problem should be pretty basic. Should be very basic now. So the second problem here should be easy. Again, in the cycle, you have evaporator, compressor, condenser, and you have the expansion valve. Okay, work going in, heat rejecting, heat going out, and energy to be cooled, no? Hindi natin kailangan condenser, and this one we just want here. And remember sa evaporator, the cooling effect there in the evaporator, it is accounting, okay? It is accounting for the total refrigerating effect. What does that mean? So let me rephrase that in terms of the energy, no? So this refers to the total cooling effect. Now, what is the sensible heat ratio? Sensible heat ratio is the ratio between sensible heat and the total heat, no? In this sense, you can say it's a total heating effect or the total cooling effect. Depends, no? But in this case, the total heat expressed as the total cooling effect. So we can say that and of course, the total cooling effect or heating effect is composed of the sensible heat plus the latent heat of cooling. So again, this is sensible heat over no? The sensible heat plus the latent heat, no? Let me just express the energy in terms of heat, because you can heat an object or you can cool an object, no? Just an expression in terms of energy. Okay? So what else can we do, no? Remember, the sensible heat, when we say sensible heat, no? This is where the equation mCpDT comes in, no? This is where the change in temperature comes in. Say you have your air, either you cool it or you heat the air, say from 27 to 50, 50 to 40. Regarding pag may temperature change, it is in sensible heat. But if you're accounting the heat from the moisture, no, or from the humidity, thus every drop or every mass of moisture or water contains energy, no? That's why you use humidity ratio. No? You use the latent heat fusion 2501 in most cases for water. But in this case, and explain ko lang, this is the general equation, no? For sensible heat ratio. So sabi, meron kang total cooling effect. So meron ka nang given itong total cooling effect mo. SHR is what? Sensible heat. Saka total, no? And remember, total heat is what? Sensible. Let me just put this in terms of Q. Q sensible plus Q latent, no? So if we would just want the sensible one, Q sensible equals total minus Q latent, no? In this case, we can say that total heat minus Q latent over total heat. Okay? So, convert lang natin yung total heat. This is in what? Total is 25,000 kilocalories per sabi per hour. So, we can just put 3,600 seconds, no? For every 1 kilocalorie, you have 4.27 kilojoules. Okay? We want in HP. Remember? Cancel to. This is in kilowatts. So, for every 0.746 kilowatts, you have 1 HP. Okay? Input mo lang sa calcu. So, you would have 38.9764 HP, no? So, lagyan mo lang siya dito, no? The sensible heat ratio is what? 0.78, okay? 0.78 equals 38.9764 minus Q latent. This is in HP, okay? Also, divided by 38.9764 HP. You would find Q latent is equal to should be around 8.575 HP, okay?